Okay, so hi there, Year 12. I'm going to be going through experimental method and control of variables and just trying to explain in a little bit more detail and to build on what is in the textbook. You should have made notes already from these pages 166 to 169. We're going to start with experimental method 166 to 167. So over the course of this little session, about 20-minute video, we're going to track all the way through from theory to aim to hypothesis. We're going to look at independent variables, and then we're going to understand operationalization of variables. And so we're going to start off with our aim. Now, you may have seen that we just said that we were going to start with theory. Our theories are things that you're familiar with. You've seen things like learning theory, cognitive load theory, even simple predictions based on current ideas and knowledge that is out there. So, for example, that sugary drinks will reduce concentration levels, that smoking will damage your health. These kinds of theories that we have can then lead to you having an aim or a purpose for your study. So aims are general statements that describe the purpose of the investigation. Now, it's pretty hard to understand this before you actually look at some examples. So let's look at some examples. To investigate whether drinking energy drinks makes people more talkative. You'll notice there's nothing measurable, there's nothing specific. We are just simply stating what we want to study. Okay, we want to study the talkativeness of people and how it's related to drinking energy drinks. Here's another example. To investigate whether watching violent films makes people more aggressive. Again, nothing measurable here, just a general statement about what we would like to study. To investigate whether using mobile phones reduces memory capacity. Again, nothing measurable, a general statement. So at the start of a study, a psychologist will take a theory that they have, and from that they will develop an aim, what they actually want to study. They move on to next is the hypothesis, and you will have hopefully met this word a number of times in science already. It's a measurable statement that predicts the relationship between the variables that you are using. So what we mean here is that we need, as scientists, to set out what we think will happen, or at least to set out the relationship between measurable variables. So there are two types of hypotheses here. The plural of hypothesis is hypotheses with an E instead of an I. So there are two types of hypotheses. There's a directional hypothesis, and this is where you make the anticipated, the predicted difference clear. So, for example, people who watch violent films will be more aggressive than those who do not. That is where you are making it clear what you expect to happen. It is in the direction that you expect. So you are putting a direction to your hypothesis. You are predicting that it is going to go one way rather than another. Then you have a non-directional hypothesis. This is where you state that there will be a difference between the two groups that you look at, but you're not going to commit to which direction that will go. So a non-directional version would be this. People who watch violent films will have different levels of aggression than those who do not. So directional, people who watch violent films will be more aggressive. We are suggesting the direction of the research, of the data. Non-directional, people who watch violent films will have different levels of aggression. So again, we are not committing ourselves to which way to go. So which type of hypothesis should you use? And you can get exam questions that will give you a study and then they will ask you what type of hypothesis would you use. So how do you make that decision? Well, directional is when we have previous research that suggests that the results are going to go in a particular direction. So for example, there's lots of good evidence to suggest that if you eat lots of sugar, your concentration levels will go down. There have been many studies into this. So if you are setting up an experiment which is looking at the relationship between sugar consumption and concentration, you should use a directional hypothesis. You should predict that it will reduce concentration by a certain amount. And that's because all of the current data suggests that it will as well. There's no point in predicting the opposite because you'll just be wrong. Non-directional is when there is either no prior research, so you might be researching a new technology that nobody has started using yet, or you might just have managed to come up with a really novel area of research where you don't know what the impact is going to be, or where the findings have been contradictory. A good example of contradictory findings would be real-life violence in computer games. So the findings for this have been contradictory for a long time. Some studies suggest that if you play violent computer games, you're more violent in real life, but there are lots of other studies which suggest the opposite. And so, or at least that they don't. And so a non-directional hypothesis would be better in that scenario where the current research doesn't suggest it will go one way or the other. Okay, now let's have a look at probably the most important slide of this entire presentation, and in some ways of the course, because if you don't understand this, you don't understand how psychology works, or in fact science. An independent variable. We start off, whenever we are studying something, whenever we are carrying out an experiment, planning an experiment, with identifying the variable that we want to manipulate, that we want to change. If we are measuring the impact on water on the growth of plants as opposed to sugar water on the growth of plants, then we would control all of our other variables apart from the type of water that we give to the different plants. The water in that example is an independent variable. It's the thing that you are manipulating, changing, or testing. So in science and in psychology, we want to control all the other variables apart from the independent variable, which we will change, we will manipulate, we will increase, we will decrease. And the hope is that when we increase or decrease the independent variable, we can see a change in the dependent variable. The dependent variable is what you measure. It's your results. It's the concentration level after eating the independent variable, sugar. It's the level of aggression you measure after the independent variable of watching violent movies or films or whatever it might be, playing computer games. So the dependent variable is the thing that you measure in the end. It is your results. So let's think about Milgram's study then. So the independent variable in Milgram's study was the participants being in the situation that they were with in the obedience experiment. And in that particular situation was the thing that Milgram had manipulated to put them into that unusual situation. The dependent variable was the voltage, how high they went on the voltage counter. Okay, let's think about experimental conditions. So the classic setup for an experiment is to have two conditions, or two different levels of the independent variable. What do we mean by this? Well, imagine that we have a group that drinks an energy drink, as the example of the book talks about, and a group that drinks water. These are the two different levels of our independent variable, the thing that we are manipulating or changing. These are called the two conditions, the conditions of the experiment, the experimental conditions. So when we change one, so once we give people more energy drink, we would expect that to then have an impact, to go back to this slide, on the dependent variable, the level of concentration. So the dependent variable will measure the chattiness for each condition and then compare. This is just the example from the textbook. So you measure the chattiness from group A and you measure the chattiness from group B, and then you compare the results, and hopefully you've just proven, probably in this case, that energy drinks make you more chatty. Now all of that is for nothing if you have not operationalized your variables. Operationalizing your variables is a really simple concept. It means that you make them measurable. So chattiness cannot be measured unless you operationalize it. If I said that X student, let's call him Steve, is 4 chattiness, that doesn't make any sense, right? Sarah over here, this other student, is 6 chattiness, still not making any sense. So what can we do? Well, what we can do is we can say, how many words is this person speaking per minute? That is operationalizing chattiness. It's turning it into something that can produce quantitative data, something that can be measured. So whenever you're looking at things like aggression or chattiness or concentration, an experiment should try to make it measurable. How do you make memory measurable? Well, you see how many number patterns or words a participant can remember within a minute. How do you make aggression measurable? Well, you get them to play an aggression game and to see how many times they choose to hurt or attack another participant in a computer game, for example. So let's have a look then at a fully operationalized hypothesis. And this is going to be a directional hypothesis where we're going to commit to one direction. So this would be, if you were asked to come up with a hypothesis in an exam, this would be what you'd go for. After watching 10 minutes of violent television, participants will use more aggressive words when speaking to a stranger than those who have watched 10 minutes of non-aggressive television. You'll see here the underline and bold bits, we've added a measurement, a quantitative measurement, a number measurement. And this means we are then going to be able to produce quantitative data. And actually, just as I'm reading that, I can make that even better because we can say more aggressive words within 1 minute when speaking to a stranger, and that will operationalize that even more. Using Instagram for 10 minutes, participants will remember fewer number patterns, again, within a minute or within 5 minutes, whatever it be, than participants who have read a book for 10 minutes. So when we operationalize our variables, we make it into a measurable, numbered format. These are now good examples of hypotheses and would be the perfect answer in the end to an exam question. Control of variables. So on to the next double page spread. So in a perfect experiment, the changes that you make to the independent variable, the manipulations, the increasing, the decreasing, the giving them energy drink, the giving them of water, whatever it might be, should have a clear, direct relationship with the dependent variable. And you should be able to say when we increase the IV, the DV will decrease or it will increase. And we know that it is the change in the IV that is leading to the change in the DV. We know the thing that we're manipulating is leading to the change in the results. However, we have a problem. Extraneous variables. Extraneous just means from outside, coming from beyond or outside. Extraneous variables are any variable which can get in the way of that beautiful relationship between the IV and the DV. Here's an example of some nuisance variables. Now we call these nuisance variables. A nuisance is a small problem that is relatively easily dealt with, but is just a bit annoying. So I can think of quite a few of you guys actually who I would describe as a nuisance. Quite annoying, but easily dealt with. And a good example here would be temperature in the room. Now, it's not hard to control for the temperature in the room, but if you make the participants who are drinking the energy drink sit in a room that's 40 degrees C, and you make the other participants sit in a room that's 20 degrees C, you don't know whether it's the temperature of the room or the drinking of the energy drink which leads to the final result of chattiness. So then that extraneous variable has got in the way of that relationship and reduced our internal validity. There's other examples here of easily controlled variables that can be a nuisance: lighting in the room, age of the participants, time of day that you do the experiment in, the kind of room that you're in, the time in the year. Is it winter? Is it summer? Is it a holiday? All of these are extraneous variables, nuisance variables, that might get in the way of the relationship between the independent variable and the dependent variable. And what I mean by get in the way is that you then do not know whether it's the IV or one of these other variables which is causing the change in the DV. Now, the worst kind of extraneous variable is a confounding variable. Confounding means confusing. So to confound somebody is to confuse somebody. A confounding variable varies systematically with the IV. Now, that might not mean very much to you. What we mean by this is that no matter how hard you try to measure the IV, these variables will keep on damaging your results. So even if you've controlled for all the other extraneous variables, the confounding variable will still be there no matter what. So let's think of our study of aggression and think about personality as a confounding variable. So the independent variable, watching violent films or not, leading to a level of aggressive language, let's say. Now, imagine how problematic it is if the personality of the participants is not controlled for. Because it doesn't matter what you do. It doesn't matter what the temperature in the room is. It doesn't matter what time of day it is. It doesn't matter if it's summer or winter or spring or autumn. The personality of the participants is always going to be there. And so they are always going to impact on that relationship between the IV and the DV. And so if you don't control for personality, that will become a confounding variable. It will keep following your results and keep on damaging your internal validity. Okay, so no matter what other variables you try to control, confounding variables will follow you. They vary systematically with the IV. This damages the internal validity, the extent to which we trust that the IV leads to the DV. That is our internal validity. You'll have more on that later on. Okay, on to demand characteristics. Now, demand characteristics are really simple. When you are a participant in a study, you are not a robot. In fact, you would be reactive. You would look at what's around you, you would look at the type of room you're in, and you would think, what is this study? Why am I doing this? Who are these people? What are they after? What is the point of this? Think about Milgram's study here. Those participants, their brains would constantly be turning over thinking, what is going on here? Is this real? Is that a real lab coat? What is this machine? How does it work? They are trying to pick up on what is going on. Now, demand characteristics are when the participant picks up on these cues from the experimenter and the situation. What this then leads the participant to do is to start predicting the purpose of the experiment and start predicting what might be in the experimenter's head. This can lead to two serious problems. Number one, if they want to help the experiment by doing the right thing, i.e. doing what the experimenter seems to want them to do, then they will change their behaviour. Now, if you change your behaviour, that's not natural behaviour, your results immediately lose validity. This is called the please you effect. So imagine here that you're in Milgram's study and you realise, oh, I think I'm being tested here to see how murderous I am. I'm going to stop now because I think that's what this study is about. That's the please you effect. You're trying to please the researcher by being a good person. You're not behaving naturally. If you're not behaving naturally, then the study is a waste of time because they're not really studying human behaviour. The second one is the screw you effect. So this is where you're in the study and you think, you know what? I'm annoyed by this study now. I can't be bothered. This study is winding me up. I'm going to sabotage these results. This energy drink study is boring, it's annoying, I've taken my time out to do it. I'm going to score 0 on the memory test because I want to deliberately mess with this experiment. So the please you effect and the screw you effect both damage the validity of the studies. Investigator effects. Now, this is another type of demand characteristic. Really simple. The investigator themselves can have an influence on the outcome. How is this? Well, they could be an annoying person. They could have an annoying voice. They could have an annoying manner. They could behave in an aggressive way without knowing it. They could be particularly tall. They could be particularly small. They could be really good looking. And they could be really young or really old. Any of these could lead to the participants having expectancy effects, where they start to do please you or they start to do screw you. It could even be unconscious cues. The investigator could ask a question in a slightly leading way. So they could say, okay, and how well are you going to remember this now? And suddenly the participant thinks, oh, I'm supposed to remember more now that I've drunk water rather than an energy drink. The researcher might be particularly friendly. The researcher might be non-communicative. So if you're trying to reduce bias, if you're trying to reduce the investigator effect, it may be that the researcher tries to be very distant and not very friendly. But that in itself could be taken as an insult by some participants, and then they go for the screw you effect. They try to damage the study, and again, our validity is damaged. How do you deal with all of these problems? Well, one way is randomisation. Randomisation literally means to make something random, to go by chance, to put names in a hat. So you can minimise the impact of these extraneous and confounding variables by making some things random. A good example here of providing participants with a list of words, so for memory games or something like that, ensure that they're randomly shuffled each time so that the choice of the order of words isn't biased. Now, if I'm asked to put words in order for a memory game, I will put them in order according to my own personality and my own experiences. I might unconsciously put some words first and some words last. Now that's going to lead to extraneous variables, an extraneous variable of investigator effects, of me damaging the validity of the study by putting my own subjective bias in. So instead what you should do is randomly shuffle those words every time. You can also randomly shuffle participants to try and deal with participant variables like personality, so you can randomly assign them to different groups, and you'll talk about that a lot more later on. Standardization. So our final point here to try and reduce to the damage to the validity of our study is to keep things the same. Have a list of instructions and procedures for exactly how the experiment should be carried out, and then standardize everything. The time of day, the temperature in the room, the instructions read to the participant, the size of the room you're in, the machines that you use, the type of paper that you use. Keep it all the same to prevent them from being extraneous variables. Remember, the only variable that you want to change is the IV. There is no use doing a study where you show one film to one set of participants and then you show a completely different film to another set of participants and then measure their aggression levels. Because you're not measuring violent films and their impact on aggression, you are measuring that film and the impact on aggression. And so you've completely destroyed your study. Okay, so as it says here, this prevents non-standardized elements being extraneous variables, light, sound, temperature, time of day, tone of voice, words used. So here's a summary of all the words that we've looked at so far, all the concepts that we've looked at, and I'm just going to very briefly trot down through them just so that you can have one final chance at understanding them. I've made the definitions a little bit simpler than they are in the textbook, so you might find this quite useful. Aim is a general statement about the purpose of your study. Hypothesis is then a testable prediction of the relationship between those variables. The IV, the independent variable, is the one you change. The dependent variable is the one you measure, your results. Operationalization, making your variables measurable, turning them into a numbered format, quantitative data. An extraneous variable is something that interferes. I think that word interferes is really helpful in the relationship between the IV and the DV. And the confounding variable is also an extraneous variable, but it's just that you can't simply control for it because whenever you change the IV, it's going to keep on changing with it. So personality type is a good example. Culture is another good example of a confounding variable, the culture of the people involved. Demand characteristics, when a study provides clues or hints. Investigator effects, when the researcher themselves provides clues or hints or it damages the study in another way. Randomization is to use chance to reduce the impact of those extraneous variables. And standardization is keeping your procedures the same. Okay, I hope that was helpful.